Okay, guys, so this is going to be example 8 from that integral as net change homework assignment. Again, there was a request for a couple of these, so I'm going to be working on a couple of them, trying to get those videos together and posted. So on example 8, you were given this graph, and we were given a couple of problems to work on. And so for problem part A, it said two runners, A and B, run on a straight racetrack for 0 is less than t for is less than or equal to 10 seconds. The graph above, so here's that graph, which consists of two line segments, shows the velocity in meters per second. So again, meters per second. There's an alert right there. Let's think about that. Make sure we get those units, meters per second, of runner A. The velocity in meters per second, so we've both got the same units, of runner B is given by the function v, defined by v of t equals 24t divided by 2t plus 3. So find the velocity of runner A and the velocity of runner B at time t equals 2 seconds. Indicate units of measure. Okay, so we've got to find the velocity of runner A and the velocity of runner B at time t equals 2 seconds. So let's start with the velocity of runner A. And so if we go over to our graph and we take a look at this and we grab at time t equals 2 seconds, now if we had a ruler, we can go over here, we go velocity t equals 2 seconds, and we can go up here and we can put a little dot on there. Actually, I should probably grab a different color, right? White's not going to work on there. And then we could, move over to this and then say, okay, it is definitively between 6 and 7. That's not going to help us out very much, is it? We need to have an accurate number. Like, we need to have an exact number of what that's going to be. And so what we need to do is come up with a formula to calculate out what the velocity is, right? This graph gives us the velocity of runners A speed in meters per second over a course of time. And so we know that the velocity is going to be somewhere in here between 6 and 7, okay? So let's come up with a formula. Well, the nice thing is that we see right here from time t equals 0 to time t equals 3, and they labeled it for us. Between those 3 seconds, we have this straight line. And they told us that in the problem, right? Consists of two line segments. So we have the straight line from 0, time t equals 0 to time t equals 3. This consistent velocity right here. And so what we can do is we can actually come up with an equation for that, right? We can come up with the equation of a line. And so let's start with the slope, right? The slope here is going to be rise over run, right? So if we do the change in the rise, so we've got from 0 to 10, so that's going to be 10 minus 0, divided by the change in the run over here. So we go from 0 to 3, so we've got 3 minus 0. So my slope is going to end up being 10 over 3, right? And now let's create a formula for this, right? So we've got our standard formula, y equals mx plus b. I'm just going to write it this way, b plus mx. Okay. Well, we've got my slope. So y equals, slope is what, 10 over 3. There's my slope. I've got an x, right? We've got x, and we need to put in a b value. Now, if I go over here to 0, that's not going to help me out a whole heck of a lot, right? 0 doesn't do anything for me in terms of the b-intercept, but I have a point up here that I can use. I've got this point 310 that they labeled for me. And this is something that they gave me. They gave me that bit of information. I could come down here. I can make the assumption that it's 0, 0, but we don't know that definitively. We do know, however, this point 310 because they gave me that bit of information. And so if I use my point slope formula, what I can actually say here is that I can put in here for 10 as my y value and x minus 3 for my x value. Right? And again, what I'm doing is I'm using the information that they gave me in the problem to create a formula that I can utilize. And so y equals this y inner slope plus my slope formula times my x values. And again, I'm using that based off of the information that they gave me. So y equals 10 plus 10 over 3 times x minus 3. Okay, so did that answer the question? No. This was just a formula for us to go ahead and answer the question, which is, what is going to be the velocity of runner a at time t equals 2. Well, now that I have a formula, I'm going to use that. So I'm going to say y of 2 equals 10 plus 10 thirds times 2 minus 3. And this is going to equal, well, 10 plus 2 minus 3, that's going to be negative 1. Negative 1 times 10 thirds, so this is actually going to be a minus. So this is 10 minus 10 thirds, which equals 20 over 3, or if I was using my calculator, 6.666 meters per second. Okay, so there's my velocity for runner A. Now I got to do my velocity for runner B. So velocity for runner B. Well, they gave us a function, right? They said velocity for runner B is defined by this function. So velocity for runner B at time t equals 2 is going to be really easy for us to calculate out. That's just going to be plug in 2 for this. So we've got 24 times 2 divided by 2 times 2 plus 3. So this is going to equal, let's see, 48. 4 plus 3 is 7. And then again, if I use a calculator to figure that out, 48 divided by 7 is going to be 6.857 meters per second. And so there we go. I have velocity for runner A and velocity for runner B at time t equals 2 and time t equals 2 for both of these. Okay, so question B, find the acceleration of runner A and the acceleration of runner B at time t equals 2 and indicate units of measure. Now remember, acceleration is the derivative of velocity. Okay, so now we're looking for the derivative of the velocity that we have. Now, so for runner A, acceleration would help if I can properly spell today. There we go. Runner A acceleration at time t equals 2. This is the slope, right? The derivative of velocity, okay? It's the slope of the given graph. Right? So if we go back, to our graph, the slope at time t equals 2, that's going to give me the acceleration. Remember, the derivative of velocity is acceleration. The derivative is just another way to say slope. And so if we go back to this, we want to know what the slope is at time t equals 2. Well, the slope is on this line, and we calculated out the slope as being this right here. The slope is 10 thirds. And so I'm going to say that at time t equals 2, the slope of the given graph at t equals 2, this is 10 over 3, which equals 3.333 meters per second squared. Okay, remember acceleration, meters per second squared. Now let's talk about runner B. So runner B acceleration. So runner B's acceleration at time t equals 2 is, now we have to be careful about how we label things. We cannot say that A of 2. We have to say V prime of 2. Okay, they gave us a formula for V of 2, V of t, but we have to make sure that we're using the proper notation on this. They never said A of t, and so we can't use that kind of notation when we're going to define this. So V prime of 2 is going to equal the derivative of this formula right here, V of t equals 24t over 2t plus 3. Now, what I'm going to do is use a calculator to figure this out. So let me pull up my calculator. And there's a couple of different ways you can do this. If you went into y equals and punched in that, that formula for V of t, then you can go ahead and use that y equals. I'm going to go ahead and just go straight to punching in the derivative. So if we go into math, and if you scroll down, you can go to math 8 is the derivative, okay? And so you go math 8 or just math, scroll down and select it. And we're going to go the derivative of, and I'm going to punch in the formula. So 24x divided by, and I'm going to make sure I use parentheses here so that way it takes the whole thing, 2x plus 3, and close those parentheses. So here's my formula. And then I'm going to evaluate this at t equals 2. I'm going to let the calculator do the work for me. And it comes back with this value, 1.469. Okay, so this is 1.469. And again, what's our units? Meters per second squared. So what's my velocity? Velocity for runner A, we've calculated out using the graph. Calculated the velocity or the acceleration for runner B, we calculated out using the calculator. Okay, now part C, find the total distance run by runner A and the total distance run by runner B over the time interval from 0 is less than or equal to t, which is less than or equal to 10 seconds. Indicate units of measure. So what is the total distance run by runner A? So let's start with this, the total distance. Total distance of runner A. Okay. Well, this is going to be the area, right? We're trying to calculate out the total distance. And what we're looking for is the area underneath this graph. Okay. And so there's a couple of different ways we can do this. What I'm going to do is I'm going to take this all out. And I'm looking for the area. Well, if I break up the area, what I'm looking for is two different kind of components, right? I'm looking for the area of this component right here and this component right here. And so the area of this first component is just a triangle. So what do we got to do? We've got to do 1/2 times the base, which is 3, times the height, which is 10. I'm using the information they gave me. So 3 times 10 is 30, times 1/2, that's going to be 15. Okay. And then for this area right here, I've got from 3 to 10, so that's 7, right? Base times height, and that's what? 10. And that's going to be 70. Okay, so let me go back over and let me put that notation down over here. Okay, so this is going to be, this is 1/2 times 3 times 10. So that was the area for that first part, plus, what do we got? 7 times 10. That was the area of that second component, right? So this is going to equal 15 plus 70, which equals a total of 85 what? Meters. That was the total distance that this person traveled, that runner A traveled. Now, what about runner B? What is the total distance of runner B? Well, this is going to be equal to the integration from time t equals 0 to time t equals 10 of what? Well, we want to do the absolute value of the velocity. Remember, we don't know if this runner ran forward and then ran backwards, so we want to take the absolute value of that. And what I'm going to do is I'm going to let the calculator do the work. Now, again, if we had gone in and punched it in y1, if I had punched that value into y1, I could just go ahead and use that. I didn't do that, and so I'm going to have to punch in the entire value. So if I go math 9, that pulls up my integration calculator. I'm going to go from 0 to 10. And now I want to punch in the value of this. So for the absolute value, we go to math, scroll over one to number. That first one right there is absolute value. So the absolute value of, I'm doing 24x divided by, and in here it's 2x plus 3. Okay. And then if you scroll over, it should, there's your bars, scroll over again with respect to x. And I'll let this do the work, and I get back 83.336 meters. And so this one equals 83.336 meters. And there you go. Okay, and that's the entire problem right there. So this was really about understanding velocity, acceleration, and total distance, and knowing how to not only manipulate a formula, but also how to manipulate a graph.